Alright, so now we're going to do two force vectors. We're going to do vector A and vector B. And if we add vector A and vector B together, we're going to see what happens when we actually combine them. Alright, so first we're going to just do a quick move this guy up top here so we have some space to work. And we're going to come over and we're going to start to do some stuff. So we have vector A. We're just going to work on vector A first. So we have vector A at 32 miles per hour at a 52-degree angle. Okay, and with that we have an X component and we have a Y component. If you notice right here, they're in a formation called tip to tail. So that's one of the key things we need to keep in mind later on. So we have an X and we have a Y. Okay, so I'm going to make a little table over here. Make a little table that we're going to use and we're going to fill up. Okay, so we're going to, alright, split it up. So we have AX, AY, we're going to do a BX, we're going to do a BY, we're going to do a sum of all forces in the X, we're going to do a sum of all forces in the Y, and then we're going to add this. We're actually going to do a resultant vector and a resultant angle. Okay. One of the first things that I like to do is I like to make sure, I like to go back and I like to see which way these directions are going. So because vector A is going to the left and up, the left-hand component is X, and because it's going left, it's actually a negative. So that's one of the first things I do. I just make sure I put a negative in here first. So we're just going to put a negative here. The Y, because it is going up, we're going to keep it a positive. Alright, so let's get to work. Oh, my fault. There we go. Okay, so let's go through. We'll do, write this up here. SOHCAHTOA. And if you don't know what SOHCAHTOA means, if you want to go back to the force vector video, it explains a little bit of SOHCAHTOA and how you use it. So I'm going to assume that you guys have an understanding of it, and we're going to move forward right from there. Okay. So we're going to go through and we're going to do the sine of an angle equals opposite over hypotenuse. Okay. Sine of 52 equals, and our opposite value, well, we use our angle that we're using, 52, and we go opposite of it. So in this case, the opposite value is the Y. So we're going to actually be finding Y. It really doesn't matter what you find, just as long as you're correctly using those opposite and adjacents. So we do the sine of 52, so it becomes 32 sine of 52 equals Y, and Y has a component, has a final value of, and when you're putting it into your calculator, you want to verify that you are in degrees, not radians. You get 25.2 miles per hour. I'm not going to put the units in yet. So our Y, we're going to come up here, we're going to do 25.2 miles per hour, which we'll worry about later. Alright, so let's move on. Let's do cosine, because cosine is going to give us the X, actually, the adjacent. It's the adjacent over hypotenuse. So cosine of 52 is X over 32. We do 32 cosine 52 equals x. And again, if it seems like I'm going a little faster, you might want to turn around and go back to the force vector video that I went through earlier, just to make sure you get that one. You can go back and forth and check it out. So we get an x of 19.7. So we're going to put that right up here. And if you notice, 19.7, again, that negative is gonna come into play later on here. Alright, so we have our first vector. We have vector A done. So we're going to come back. We're going to jump into doing our next one. And I'm just going to put it right here. This is vector B. And vector B is 75 miles per hour at a 20-degree angle. So we're going to put in our x and our y, and x is the adjacent in this case. Still, not just because x is always adjacent, because it's next to our angle, our degree angle right here. And our y is our opposite. Alright, let's just check our negatives, positives. X is going to the right, and y is going to the right. So they are both positives. We don't really need to worry about making them positives or negatives. Okay. So again, we're just going to do sine. Sine of our angle equals opposite over hypotenuse. Sine of 20 equals opposite, which is y, and 75. 75 sine of 20 equals y. 75 sine of 20, and you get a value of, again, just about the same, 25 point, really, I'm going to round that up, 25.7. I'm doing a little bit of rounding, but just for the video. Cosine adjacent over hypotenuse. Let's go back. We're going to put this in here. This is vector B in the y direction, so we're going to put it right in by. So 25.7. Great. And we'll do our cosine here. If the computer wants to. So cosine of our 20-degree angle equals x over 75. 75 cosine of 20 equals x. And x is should be much longer because it's much longer, so we get about 70.5. Okay, just so 70.5. So we get a negative 19 because it's going left. We get a positive 25. We get a positive 70.5 going to the right, and we get a positive 25.7, and it's going up. So that's how we go through. It's basically just finding two separate vectors, and then this is where we start to combine them. This is where we start to combine them. So what I'm going to do here is I'm actually going to erase this stuff. And again, because it's a video, you can always go back. The nice thing about videos is you can always go back. You can turn around. All right. So now we're gonna add up. We're gonna add up our sums here. We're gonna add up right here and right here. We're gonna add up our x's, and we're gonna add up our y's. All right, so we'll do it in a different color. I'll just kind of put a dot here. All the oranges are the same, so we get a and we'll just put an x in the x direction. We get a negative 19.7 plus, we're plusing, we're adding because it's the sum of, and then we're going to do a 70.5. So we get a negative 19.7 plus 70.5, and we get a final x value of 50.8. Alright, and we can come in here, 50.8. Alright. And we're going to do this in greens. We're stay on the same page. Take our y, we get 25.2 plus our 25.7 equals y. We get a y component, we get about 50.9. Now, because they're both positive, we can kind of see what directions they're going to be moving. So let's just put these in here. So we'll do the y first because it's a positive. It is going up. And a curve there, 50.9. And we're going to do our orange for x. And because it's x, we're going 50.8. It is going to the right. Okay. Now, mind you, this is not drawn to scale, so it will seem like a little off. As you notice right here, we're going tip of one. We're going tip of one to the tail of another, and we're going to draw our last thing here, and we get an R. So that's what we're looking for. We're looking for the resultant vector. And then this is going to be our resultant angle. So basically how we can do it, easiest way to do it is we can do Pythagorean theorem, a squared plus b squared equals c squared. So we do, doesn't matter which one we do, 50.9 squared plus 50.8 squared equals c squared. So once we do that, we do 50.9 squared. We get about 2590.8 plus 50.8 squared, and almost the same, 25,980.64 c squared. We're going to add them together. We get about 5171.45 equals c squared. And in order to get rid of it, we do a square root. And we do square root. And we get a final, basically an R value of 70, not 70, almost, a little over 70, 71.9. So about 71.9. 71.9. Okay. And the last thing we got to do is we got to find this resultant angle, which is this angle right here, inside that triangle. So again, I'm going to come up here. I'm just going to do a quick erase. Again, you can always go back, you can stop, you can pause. Kind of saves us time for you having to wait. Okay, so we have 71.9, and we have a 50.8 and a 50.9. So we can really quickly, we can just do a quick jump here, because this is the angle we're looking for right here. This is the angle. This is obviously opposite. and this is adjacent, and this is hypotenuse. So we can use either one of these. We can use sine, we can use cosine, or we can use tangent. Really doesn't matter. If you want to use tangent, you can use tangent, use sine, cosine. I just always use sine. I try to use sine for everything, just because it's the first one. So sine of an angle equals opposite over hypotenuse. The angle we don't know. We're going to keep it theta. Our opposite value is 50.9. And our I think this rounding is going to throw us off a little bit. Let's actually do the I think because I rounded a little awkward somewhere, I'm actually going to do tangent. We're going to jump the tangent. We're going to use tangent. It was close. The calculator really wouldn't like it. So let's try with tangent. So tangent of an angle equals opposite over adjacent. Okay, so tangent of an angle equals 50.9 over 50.8. Okay, when we do 50.9 divided by 50.8, we're going to get a value of tangent angle value of almost 1. We're going to just, so 2. And the way we need to get rid of it, we really need to get rid of this tangent. So the way we get rid of it is we basically do a tangent -1. We do the inverse of tangent. So we basically divide by tangent. And what that looks like, do this in a different color. Tangent, both sides, tangent. And what that looks like in your calculator is it basically looks like this. Come up here. Tangent -1, and what you're going to do is you're going to put in the parentheses on your calculator. Good thing we have calculators. It saves us time. You're going to put that 1.002, and that's going to equal our angle. So we basically are getting rid of it. When you do that, when you put it in your calculator, you're going to get roughly, amazing when I make these, sometimes they work out very nicely. We get about 45 degrees for our angle. So our angle is actually 45 degrees angle. So this vector A and this vector B are pulling with 32 miles per hour at a 52-degree angle, and a 75-mile-an-hour vector with a 20-degree angle is actually going to result in an angle. Again, this is not to scale, but it's close. It's pretty close. Nothing that's so far off. We're going to get an angle of roughly, it's a little tall, but 45 degrees at a 71.9 miles per hour. Okay, so like I said, at any point, if you miss something, we didn't get it, just turn around, fast forward, back up, rewind. You can pause just to see what it is, and I hope this helps, and